Let's start the year, and oftentimes for homework you will have video notes to do. So this is our very first lesson, Module 1, Lesson 1, and let's call this the building blocks of geometry. So the terminology that we're going to list today is used, and the rest of the course really does rely upon these three terms that we refer to as undefined terms. So we're going to make a chart here. We have undefined terms in this first column, and I'll show you how we represent them. We represent these terms with, and then we'll describe it in words or with a picture. We'll give a description of each. Okay, so these are going to be our three columns. And the first undefined term is a point. And of course, you represent a point, what it looks like is just a dot. That's what the point looks like. It doesn't matter how large I make that dot. If I'm heavy-handed and it's a little bigger, it doesn't matter. It's just a point, and the size does not matter. We represent it with a capital printed letter, meaning it's not going to be in cursive. So over here, this might have a letter next to it, and if I just write A, by default, I'm going to read that as point A. When you see a capital letter all by itself in geometry, that means it's a point. So we would read this as point A. That's what we would say. And what do we know about a point? Well, like I said, it doesn't matter how large I make this point. The size is irrelevant because it has no size. And when we say it has no size, what I mean is it's non-dimensional. And what it is it is just a location in space. And the best analogy, or the best example, I can give you right now, just having come out of algebra, would be something like the coordinate plane. And if I ask you to graph the ordered pair -3, +1, you would go left 3 units and up 1 unit, and we would all put that dot in the same exact location. And it didn't matter how large we made that dot, we were trying to represent the point that is exactly at the spot 3 to the left of the x-axis and 1 above the 3 to the left of the origin and 1 above the x-axis. Okay, so that's a point. All right, our second undefined term. And once we accept that these three terms are what they are, we use them to define pretty much everything else that comes along. So the next thing is a line. And we show a line. If I just did that, that's just part of a line. That's a segment. We need to put arrowheads on the end to show that it goes forever. So the line is infinite and it has to have arrowheads on the end of it. I'll come back to this in a minute and add some more to the picture, but really that's what a line looks like. Let's just say it goes forever. In theory anyway, lines are infinite, okay? So how do we represent them? What does it look like? We'll come back over here, and there are two ways to represent it. A line is made up of an infinite number of points that have just aligned in some straight arrangement. So there's an infinite number of points on this line, but if you're going to name a line using points on the line, you have to know at least 2 points on the line. So let's say this red line I drew passes through points M and N. One way to name that line would be to call it, you put M and N right next to one another. which in algebra means that you're multiplying those two variables together, but these are not variables in geometry. These are capital letters, point M and point N. You put them right next to one another, and then you draw the line symbol over the top, and we read that as line MN. Or the order doesn't matter. It doesn't have to be alphabetical. It doesn't matter which one you put first. These two things, they name the same line. Okay, so one way to name a line is with, what do we do there? We use 2 points on the line. I'm trying to keep this all in this middle column here, okay? There's a second way to name a line. And so it's important that you do keep track of the notation, because if you fall behind here, it can just sort of leave you behind if you're not careful. Another way, and you'll see this from time to time, is there might be a lowercase cursive letter just kind of near the line, but not on it. So for instance, maybe we had a lowercase cursive D. That's not a point. It's just some notation. We could also call this line D. Okay, so you can name it with just this lowercase cursive letter. Let's write that. This doesn't look like a D, does it? D. Or you can name it with a lowercase cursive letter. Okay, and what do we know about a line? A line is one-dimensional, even though technically you can't measure it because it extends forever. It has one dimension, it has length only. It doesn't have width, doesn't matter how wide I draw that line, it only extends so that you would be looking at the length of that particular line. It's one-dimensional, and as we said, it's made of it's a collection of an infinite number of points that line up, if you will, that line up. That's not a real formal definition, but that's what we're talking about, okay? So that's a line. All right, the third term, so our undefined terms are a point, a line. The third one is a plane. And a plane is going to be a flat surface. This piece of paper is a finite plane. The table you have your paper on is an example. That tabletop would be an example of a plane. And we represent planes in geometry. The shape is actually a parallelogram that we use to represent planes. Kind of rectangular, but length and width, rectangular. We represent a plane like such. And a plane is made up of an infinite number of points and lines, just all passing through this area. If we're going to name a plane using points, we have to use 3 points in the plane, and those 3 points cannot all be on the same line. So for instance, since we can see the line of my paper, if that's point R, and I also had point S, I can grab a third point in this plane, but it can't be another point that's on that line. So let's just say that point T is down here. I can call this, so one way to name it would be plane RST. And again, the order of the letters doesn't matter, but what's important is that we've got 3 points.
Miss Jordan, please stop by the front
not
office to see Miss Miles before you leave today.
on the same line. 3 points not on the same line. Plane RST. Okay, there's a second way to name a plane, just like we have 2 ways to name a line. Or if there happens to be a capital cursive letter in the plane, so it's usually going to be near one of these corners. So maybe we've got a cursive M just like this, in the plane, then you can simply name it, or we could simply call this plane M. Okay, so what is that? It's a capital cursive letter. All right, again, in theory now, a plane is going to be two-dimensional. It extends in two directions. It extends with respect to width and length, base and height, two-dimensional. And it is made of an infinite number of points and lines. Infinite number of them all throughout that plane. We wouldn't want to write them all. Okay? All right, let's just simply do some more definitions. So there are three undefined terms in geometry, and there they are. Okay, now just a couple of more definitions, and then we'll do a quick example and we're done. So, definitions, collinear. So we're going to define collinear, and while we're at it, we'll go ahead and define coplanar. So I'm sure you can see that the root word here, we've got line, and we also have plane here. Co means hanging out together, if you will, co-workers, people I work with. So collinear points are simply going to be, if they're collinear, they are points on the same line. Here's a quick example. Got a line, and we have points A, B, and Q, and then we also have point S, okay? We can say A, B, and Q are collinear. They're all on the same line, but we also can say that A, B, Q, and S, all four of those together at the same time, do they lie on the same line? No. So we say that they are non-collinear. Non, of course, meaning not, okay? Points on the same line. So coplanar, what are coplanar points? They're simply going to be points in the same plane. So let's just quickly draw an illustration of that as well. So here's my plane. I have X, I have P, I have T. There you go. So we can simply say that points, remember, I don't have to write the word point in front of that. It's capital. That's what that means. Point X, point T, and point P are coplanar. They all lie in the same plane. They all lie on this piece of paper. If there were another point, so I know this is maybe hard to see, but I'm coming up off my paper. If this point is up here, this point, this little dot on the tip of my finger, is non-coplanar with those points. It's not lying down there in the same plane. All right, a quick example, and then we will be done. Okay, so example. What might you do with just this basic information? Well, what if you had to draw a picture? Draw and label the following. Here we go. I'm just gonna write it, and then I'll go back and read it. So I want you to think about what we learned with respect to the symbols on the previous page. And what am I writing? What does that mean? So just copy it for a moment. Okay, so that's a lot. So I don't have graph paper. Clearly these are ordered pairs. Graph paper would be nice, but we'll just go ahead and we'll just quickly make a quick graph here, okay? I'm not too worried about it being super accurate. It looks like maybe 1, 2, 3, 4, 5. Okay. All right, what does that mean? I read that, it's got the line with the arrows. I read that as line JK. And this is point J. And point J is at -1, -2. Point K is at 4, -2. And what do we know about J and K? I know there's a line that passed through them. Let's go ahead and draw that line. So line JK looks like such. I'm not going to forget to put the arrowheads on the M. We have point L, which is at -3, -3, and M, which is at 1, 5. Here's M. We have line LM. So I'll go ahead and draw that line. And they do intersect, and where they intersect is a point. But am I going to put Q there? Maybe, maybe not. We don't know the exact location of Q, but we know that it is collinear with line LM, but not JK. So it doesn't lie on the same line as points J and K, only the line that contains L and M. So LM is this line. I don't know where I'm going to put Q, but I'm definitely going to put Q so that it's not on the line that contains J and K. Okay? I forgot. I do have one more thing to say. Sorry about that. 2 quick fact about intersections. If something intersects, you guys know what an intersection is. A1A and Pineda, they intersect. Pineda heading to the beach, A1A, they meet. To intersect always means that they're going to meet or touch. Okay? So intersections. If, this should just be a bullet, if 2 lines intersect, 2 lines intersect, where are they going to meet? Or what is formed where they meet? They intersect at a point, right? Those 2 pins cross, right there where they meet is going to be a point. And planes, if 2 flat surfaces intersect, 2 planes intersect at a, so let me just quickly show you this. We can talk more about this tomorrow if we need to. Let me zoom out for a second. So this piece of paper is a flat surface. It's a plane. And if I move this around, this is also a plane. Where does this plane meet or intersect this one? Remember, I want to know where they touch. This plane touches that one right here along this ring. And what is that? That's a line. So where do 2 planes touch? They're always going to touch at a line. 2 planes intersect at a line. All right, we'll practice all of this when we're in class.